Hi guys, welcome to Introduction to Houdini Particle Effects. That's the first chapter, so we have to think about the particles, we have to understand how it works and why we are going to use particles in visual effects and computer graphics scene. So the first step is starting to understand how particle works and why we are using it. So we move inside a 2D software just to understand what's going on. So you know that inside Houdini we have a lot of stuff related to visual effects. We have the particles, and for particles we have the pops. We have the dynamic that is linked to particles, and we are talking about DOP, so dynamic operator and particle operator. And then we have a lot of more stuff inside the various context networks. We have, for example, the SOP, and we are talking about surface operator. We have the BOP, and with the WOP, we are talking about VEX operator, so we can create some kind of, task, and let's say maybe something similar to a plugin, or maybe a program that is using nodes to do stuff, so we don't need to use the VEX scripting language. So everything can be connected with the other stuff, so we can have multiple connection between the various stuff, so everything is really powerful inside Houdini because we are talking about a procedural approach. We have obviously a more operator, but the main is the POP network for us. So we are talking about POP network, okay, because we are talking about particles. So this one is a DOP, so let's think about as a DOP because it is a dynamic operator, but it is working over a particle system, so it is useful to generate particles. So what is a particle? Let's think about it over a new image. So a particle can be a point, so let's say that this one is a single point, or you can imagine the particle as an object, so let's say this one is an object, okay? So we can imagine to control more points or objects over a single dynamic operator. What I mean is that if you like to animate a single object, for example, or a single point, let's imagine that a point can be a sphere with a really small scale. If we like to animate just one in a dynamic way, we can do, for example, let's say that we have the standard keyframe animation, because if you are obviously a really nice animator, you can do it. Or if you like to have the dynamic, so collision and stuff like that, everything done in dynamic, you can use the DOP. So in this way you can control using a mesh, or maybe a really small mesh for a point, you can do in this way. But what happens if we have to do something like that with, for example, 30 million meshes? It is obviously impossible. What I mean is that you can't animate by hand 30 million polygons, 30 million meshes, and doing something like that with the DOP is really complex, because you can do obviously the dynamic, but let's imagine that we like to control the behavior. So the really important thing is that we can control the behavior of our mesh inside the POP, because we have a lot of nodes to control how the particles are behaving and how we like to see the particles moving. So for example, if you are talking about dust, you are talking about debris, we are talking about magical effects or stuff like sand or for example, let's imagine a galaxy or stuff like that, you know. It is something we can do inside the POP networks because we can control a lot of stuff directly with a single network. Let's see in another image how the particle works. We can imagine that the particle is essentially an object, okay? Just a single object. Every single particle has a lot of property, so we have an ID to see, to control the single particle. We have the age, we have the life, we have the velocity, and we have many attributes, you know, many properties, and we can control everything over the particles. We can access to this data without any big problem inside Houdini, but it is the same in the other 3D software. So the main thing is that a particle has a birth event, so there is the birth at one frame. Let's imagine that the frame 0 is when the particle has a birth, and then usually we have at this event, let's imagine that the particles will be killed at frame 100. So what I mean, in this case, if we see this time frame, the age will be 0 there, and for example 50 there and 100 there, you know. So I'm talking about frames, obviously. And about the life, it is how much frame. So life will be 100 frames, and the age will be something that is related to the frame number. The ID is the particle number. Let's say that now is called something like particle number, pnum. By the way, we'll talk about it later inside Houdini. The velocity, or let's talk about speed, is how it moves over the 3D space. So we'll have a vector that is based on the speed over the x, y, and z axis. Okay, so if we think about something like that over just the 2D space, let's imagine a new image to understand how it works. So we have again our particles. That's our particles. We have the frame number. So we can say that that's the life. Okay, so that's life, and let's say age also, because there we have the total amount of life. By the way, we have step by step the particle age. Okay, so that's the age, and that's the total amount of frames about the life, the particle life. So these particles will move over the time, because that's the time, but it can move obviously over the space. So we have the 3D space, and to move it we have a speed. So for example, if we have a speed, let's say that speed is 0, 1, 0, it means that we have a speed of 1 meter inside Houdini over the y-axis. So it means that every seconds, and we are talking about, let's say that the seconds is 20 FPS, so FPS. So we are talking about 34 frames to have a second of animation. So it means that the particles will move over the y-axis 1 meters per seconds. Okay, so it is rising up. Obviously, if we have a speed of, for example, let's say 1, 1, 0, that's the speed, the new speed, we'll have the particles moving 1 meters by seconds over the y-axis and the x-axis. So it means that it will move in this way because it is rising up over the y-axis and it is moving over the x-axis. And that's the same if we have a speed, obviously, over the z-axis. It will move over the 3D space. So that's essentially the speed. And another important thing is that the speed is moving, and the speed, or let's call it velocity, can be controlled in various way inside the Houdini. We can have the pop forces. We have a lot of forces inside the pop networks, and we can have, for example, the volumes and the fluids. And in this case, we are talking about velocity fields. So we have the possibility to do some stuff with the volumes and the fluids, and everything related to the possibility to control the particle position and the particle velocity. It is called advection. Okay, so that's really simple. We can control the position, the velocity using pop forces, various pop forces, and we can use also the velocity fields created using volumes or fluids. And that's something we are going to do inside our coming lesson. And another important thing is that obviously velocity and forces are linked together, because we have a velocity, but the forces can control how the particle moves. What I mean, let's imagine that we have another image. Okay, we have again our particles that has a speed, let's say the velocity is 1, 0, 0. Okay, so it is moving just over the x-axis, and let's imagine that that's the y-axis and this one is the x-axis. Okay, so over time our particles is going straight over the x-axis. Let's imagine that we have a pop force, and we'll see how it works. And this time it is based on a noise. You know that the noise is a random function, so it will give us a random noise over the coordinates during the time. And let's imagine for our, obviously just for the scheme, to have the force applied just over the x-axis. And this means that if it is creating something like a random value of, let's say, between 0 and 1, it means that it's adding or removing this force between frames over the velocity. So it means that the new velocity will be, the new movement will be something like, you know, a random movement, because we have every time a random position over the x-axis, because it is moving in a different way, you know. So sorry, that's something, it will give us a wrong information. So it's better to imagine that this one is applied to the y-axis to have this one. Obviously, if we are thinking about these effects, so let's say that if this is applied to the y-axis, we'll have this kind of movement because it is moving at the right speed over the x-axis, but we have the random over the y-axis. If we are thinking about this one applied to the x-axis, we'll have something strange because we have, you know, the speed will be randomic, so it will get half, it will move forward and then backward and then forward and then backward every time, because we have a noise that is moving with a right velocity, and then we have the force that is going back with a value between 0 and 1. So that's something really complex to imagine over a graph like this one. So it is better to imagine the pop force applied to the y-axis. So as you see, we have a lot of forces. Obviously, we are talking about also dynamic forces. So we think about dynamic forces. The first one we can imagine is the gravity, and we can have it. Gravity. We can have, for example, wind. We can have collision, and the collision will create new forces, obviously, so the particle can collide with other meshes. It will be really interesting to see how it works. So, for example, we have this kind of forces, but we can have, for example, a drag, and a drag is just like a resistance. It is just something that will rise down the velocity step by step. So we have a lot of things there. So it is really interesting to know that with the particles we can control a lot of points, a lot of meshes, a lot of dynamic meshes. We can do magical effects. We can control, for example, let's imagine a bunch of objects. We can think about particles also for scattering, and for if you like to control a simple crowd, or for example a flocking system to control, let's imagine what we can think about, for example, foliage moved by wind. We can think about fishes or birds or something like that. So we have a lot of usage. In this first workshop, we are going to see some usage of the pop networks. We are going to see how it works, how we can use it, and we'll go to create something really nice related to the particle advection and the space effects. So let's move forward inside Houdini to understand how we can create particles. So guys, that's not a Houdini courses, so we can imagine that you have some basic knowledge about the side effects software. By the way, we are going to explain some stuff when we play with it. So I'd like to have more space there, so I'm raising up the network space there, and we can have the parameters using the P key. That's the space, the 3D space, that with the Alt key and the left mouse button we can orbit, and with the right mouse button we can zoom in and out. And with the middle mouse we can have the pen. We can do the same, obviously, without the Alt key. Okay, so you can do both. So for the moment we can stay with this kind of configuration there. By the way, we are going to use the geometry spreadsheet because we need to have information about our attributes and our meshes inside Houdini. By the way, later we are going to take care about the UI to have a better control over everything. So later we will take care about also the project creation. But it's not a problem to start with something really simple. We have many ways to create particles. We have the possibility to create particles by hand, so we'll take care about creating a pop network from scratch later. By the way, we have a shelf to control the particles, and you have a lot of stuff really there. So some of them can be useful. It will be helpful to use some stuff from there to create particles, because it's really interesting to see how the stuff are created and by Houdini. Here you see that we have the other stuff, and we are talking there about particle fluids. So you have to take care about particles for the moment. We are going to use fluids later, maybe the pyrofluids, to control the particles, but it will be a step we have to do later, because we have to understand how particle works. So the first thing we can do is, let's create with the top key, we have the menu, and we can say, let's create a geometry. We call basic emitter, so we go for something really basic at the beginning, just to understand how it works. Oh, sorry, there is a problem with the keyboard. Okay, so it is done. Let's go inside. Inside we can create a new mesh. You know, there are many ways to do stuff inside Houdini. So for example, you can also think about writing sphere there, and you can create the object without any problem. So I was saying, if we go there and we write sphere, we'll have a sphere, and that's a geometry node within inside the sphere. So we can do the same thing in many ways. So let's go there, and there with the tab key we can write sphere. Let's call it emitter, sorry, with just one ham. And we go to say that this one is a polygon mesh. And let's go with more frequency. Okay, that's our mesh. So now we have an object. We can select the object and say, let's use this one. This one is going to emit particles all over the different direction. So it will be an omnidirectional emission. So let's select this one and enter key. Okay, everything is done. So let's see what's going on. It is creating some new additional nodes. You see that there we have a top network. It is a dynamic operator. We can use the L key to have the layout. By the way, it's inside there is a pop solver, so we are talking about a pop network. And this one is just a DOP-IO. This one is just to import the particles and show the particles. So stuff will be simulated there, and there we are going this one using this one to, for example, for caching, or for example to render the stuff. So that's the node that is visible in rendering, and this one is not visible in rendering because it's just done to make the simulation. Inside our object there is nothing else. So this one can be called let's say sphere particles. Let's go inside. First of all, one dot network, in this case a particle operator, as it's a simulator, so you know you have the possibility to reset the simulation, decide some information there, and the first important thing is that it is going to create caching in RAM to show in real time the simulation. So inside cache you can decide how many megabytes or gigabytes are going to be used for the simulation. In this case we have 5 gigabytes. It means that it will use 5 gigabytes of RAM to store the simulation. When it will be over, it will delete the frames and it will use just this area. If you like to have more frame inside the caching, you have to use more memory. By the way, we'll talk about it later. It was just to understand what's going on. Let's go inside the DOP, and that's what he created. So it's really simple. First of all, let's go a little bit nested. If we go to play the simulation, you see that we have particles falling down, and that's because you see that now the time bar is blue, and it means that this part is cached, so it works in real time, and this area needs to be cached. So the blue area is going to inside the cache memory we set before. We are talking about the 5 gigabytes. Let's go to control the timing, and we can control the timing there. So now it is playing in real time. You know, it is trying to play everything in real time. Okay, so that's our animation. Okay, so what we can find inside the pop network. We have some objects. First of all, we have the pop object. This one is the, let's call it the container. Inside this object we have the particles, okay? So this one is waiting to have particles inside, and everything will be simulated, and then the particles will be available there. So if you like to pick particles out of the pop networks, you have to relate to the pop object 1 in this case, but you can rename it without any problem. The pop source is the source, so what I mean is the emitter source in this case, you know? So it is saying which is the object emitting the particles, and this giving some basic information about the bird event, some attributes, some initial velocity and stuff like that. So in this case, let's say that we like to see to hide all the meshes that are outside this context, okay? You see that we have still the sphere, and the sphere is still visible because the pop source has this option, the guide, and it's set to blue. The guide is the emitter, so if we set to off, you see that we have no more guide, we see no more the sphere. By the way, if we have back the ghosting, we'll have, obviously, the sphere that is outside this context. So then we have a merge node, and this one is useful just to, to have more particles coming inside the pop solver. So if you have more sources, everything can work together and go inside the pop solver. The pop solver, you see that there is a brain, as the other solver is the algorithm that is trying to solve the simulation. So this one is the area where we have the calculation about the speed, the movement, the collision, and everything that is related to the dynamic stuff. We have three inputs. We have the pop object, the pop source, and then you see that this one is the press solve, and here we can go to merge other things that maybe we'll see later, okay? So everything goes out to a merge node, and this one is useful if you have, let's say for example, a multi-solver, because we have more solvers working on more dynamic stuff and playing everything together, or if you have to control the collision with other meshes, because we'll have collision going inside the merge, so we have the particle solver and the collision meshes working together inside the merge. Everything that is going through the merge now has a gravity, the gravity node. This one is the force, the gravity. You see that the force is just over the y-axis, and it's the Earth-like gravity. And then we have the output. That's just the output about everything, and everything will be set out, so everything will goes inside the pop objects, and then we'll find it there inside the DOP IO. And you see that actually if we check this one, how it is important the stuff, you see that we have a DOP network, it's sphere particles, so it's this one, and then we have DOP node, and you see it is relating to pop objects. It's where we have to pick stuff to merge inside this node. So it is picking this one and moving to the other context. So you see it's really simple, and it is really clear how it works. We're going later to create our own pop networks from scratch. By the way, just to understand how it works, let's imagine that we are at frame 95 and we decide that we don't want to see the gravity, so we set to off this one. You see that the bar now is no more blue, and it says that until frame 95 is orange. It means that actually the cache is no longer usable because we changed something inside the pop network, So it means that we have to go back and we have to play again to have the simulation. So you see that now without the gravity we have the omnidirectional particle emission as we said before. So it is going to work as we say, and it's really simple, okay? So it is how it is working. You see that the particles are flying away all around, and we'll have there the information related to the bird. So you see we have the amount of particles, we have the life, we have the variance about the life, so we can decide how it is playing. And then we have the velocity too, So let's imagine that, for example, you see there we have the iris velocity, but we have no velocity stored before the emission. Then we have the velocity that is set to 0, 0, 0. So it means that we have no velocity over the x, y, and z axis. But we have a variance, and the variance is 1, 1, 1 over both axes. It means that actually we have 1 meters by second of velocity over each axis, and it is a variance, so it means that the velocity is -1, is between -1 and 1 for each axis. If we say, for example, that we have no variance over the x and over the z, let's go back and we say play, you see that the particles flying away over the y-axis to the top and the bottom of the viewport, and that's because we have the variance, so they are moving with a velocity that is between -1 and 1. If we say, okay, we have no variance, we have just the speed of 1 over the y-axis, you see that the particles are just flying away over the y-axis, okay? It's the same if we say 1 and 1, obviously we have particles flying away over the three axes together. But we have no variance. If we say we have no speed there, no speed there, and we have 1 over the y-axis, and we have the variance about, let's say, 0.5, it means that the velocity is between 0.5 and 1.5. So if we go there, you see that we have some particles that are flying away faster and some particles that are flying away slower. Okay, so that's really simple. And just to work a little bit with it, we can have back to gravity, and inside the bird we can say, for example, that we like to have more particles. So let's say, for example, 50,000, we have more particles at the beginning because the particles are created since the first frame. Later we'll see how to control the framing, but we have the max point per frame, so we can have no more than 1 million particles per frame. Okay, so that's just a breaking about the particle number. If we go to play, you see that the particles are really much faster, and we see that the particles are flying a little bit up and then are falling down. That's the velocity, and then we have the gravity. So the gravity is obviously higher than the velocity, because the gravity is -9.8. There the velocity is 1. So if we say that we have, for example, 10 and we have a variance of 2, we'll have the possibility to see the particles flying away and then falling down, because we have more energy at the beginning. Let's try with something less powerful. Let's try with 3. You see that the particles are flying away to the top and then are falling down. Another interesting thing is the life. Let's say that we have a little bit more velocity and a little bit of velocity over the other axis too. Let's go back to the bird. You see that the life expectancy is set to 100. It means 100 seconds, okay? If we say, for example, that we like to have 1 second, particles are dying. You see, when we have the time set to 24, it means that the particles are dying at frame 24, okay? We can try to have, for example, 1 particles. It's not so simple to see how it works, but we can try. So let's go there, and inside the geometry, let's say that the point is 10, so the particles will be bigger. You see, let's try with a bigger scale, maybe bigger. Okay, it is a sprite essentially. Okay, so you see that the particles flying away. We have another particles, and we have obviously to take care about the numbering and the animation in a better way to be more precise. But it is nice to see that we have the particles that is flying away, and you see that's the frame 24, 25, 26, and then that's over. So it means that we have, you see that the particles are essentially coming up at frame 3, so that's the bird event, and then at frame 27 the depth, so we have 24 frames, okay, 1 seconds. Let's go back to a better visualization. Okay, let's try maybe point size set to 3, and let's go to an higher number of particles. We need an higher scale, let's say 5, and let's say that we have 200 particles. Okay, you see the dots are falling down. If we have, for example, let's say a life of 2 seconds and we have 1 second of variance, it means that some particles will die at frame 1 when it has, second 1, so 1 second of life, and the maximum is 3 because it is a variance, so it's -1 plus 1. So you have to use this number, the life expectancy, and then you can have the -1 and +1. So we have a life expectancy between 1 and 3. So that's interesting because you can control in a better way the life. Okay, so we saw just some basic information about the particles, and we saw how the particle, the pop network, is created automatically. Now we have to understand some more interesting thing about the particle emission and the particle control and all the other stuff related to the forces and stuff like that. So let's move forward to the next lesson.